started working on this plan, and now what we are going to do is we are going to find the intersection between our functions and our plan boundary. So as you see, we created already this, but this might have a slight change here. The reason why we are having slight change here, because we are having meeting room kind of in the same organization, right? So it has like two curves that are coming in, and when we are having these two curves, what we see, we have 6 polylines. And in order to avoid that, if we grab Entwine, for instance, if I connect this and connect this, you'll see that we have like not curves as single entities. Instead, we are creating branches. Therefore, let's use Entwine, okay, not this one. So we connect this with my same selection order, okay, and this is the result. So we have 2 meeting rooms, that's why we are having it. And so we're gonna get the curves, they're all grafted. The segments are the segments that we want to have, but we have to be careful with one thing. As you see here, we have some sort of corner positions, right? Like we have this and that, but our panels, on the other hand, if you remember our panels, they are working with only center one. So we have to, or we need to kind of take out the corners of each room if we have any. So how we can extract that? If we grab an like the control points of each curve, we need to see the number of the control points that we are having, right? So we have, like, if we grab a list length, what we are going to see is at some point we'll see some locations that we have. Can't see it right now, I think. But we are having some locations as 3, as you see. And those are the ones that we have the curves like this, or we don't have points. Maybe we can turn this off. You see, we don't have any corners here. So what I'll be doing is I'll be flattening this list, and then I'll be dispatching my segments if they are not equal to, if their control points, number of control points is not equal to 2. Okay, so I'll grab an equal first point, second point, first point, second point, sorry. And if I connect this over here, and you'll see that we have false there. So if I connect this, I'll be working with the curves that doesn't have any corners. So if I grab a curve, you see these are my curves now. You see the green ones? We exclude the corners, okay? And obviously if we change this, like 2.5, we'll have maybe different corners. You see that? We have different corners, different locations. That's all good. All right, let's switch this back to 2. And now these curves are a bit important. And why don't we like group this one here and group this one and group this one too? Because there are 2 different operations. Okay, and if we grab the midpoint point on curve, say point on curve, this is my point on curve, and if I connect these points here, Now what I'll be seeing is the relationship. In the relationship, if I hover over, what it says is 0 outside, 2 inside, 1 coincident. Coincident means they are overlapping, and that's something we are looking for. And either it's 0 or either it's 1 or 2, it's going to be understood as true, unless it's 0, which is going to be converted as false. So if I create a dispatch here, and based on this dispatching pattern, if I dispatch my curves, what I'll see is I'll see a list with 5 different branches that has different values, So what we are going to do now is, if I grab a curve and connect it over here, and if I grab a tree branch just to show you, and if I simplify this and create a path that is changing between 0 and 4, you see 0 is the admin offices, and I'm taking the admin office curves. So if I preview this here off, and maybe preview this off, you see I have my admin offices, and I have the next is the conference room, the entrance, meeting room curves, and open office curves. So what I have done here is basically created all this within the tree organization that I wanted to have. And if I extrude them onto Z direction, like you see, they're all extruded on one. But if I come over here and then create sort of a gene pool and then edit it between, like, we will have 5 genes as simple as this, like let's say 5.2 to between 4.0 to, like, let's say, I don't know, 8.5. Okay, randomize it again. If I connect this over here, and if I graph this, you see my admin offices are going to be in this height, facades, this is going to be in this height, this is going to be in this height, it's going to be this height, and so forth. So that is basically pretty much it for this video. Now we have this, and in the next one we'll take our panel strategy and try to apply it onto different spatially differentiated panels.